Natalie's going to explain to us how she did the bell ringer. Make sure when you explain it, make sure you tell them exactly what you did and talk kind of loud so that way they can hear you on the camera because they really can't see the board.
So I just added up on this plane 20 plus 40 to get 60, and then I subtracted that by 180 and got 120, which is this angle. And then these are congruent, so I did 120 plus 39, got 159, and I did 180 minus 159 to get that angle.
Okay, so you got 21 degrees for your final answer for that angle with a question mark. Okay. Bailey, tell us, do you agree or disagree? Yeah, very good. And I like how you went through and you explained each part, why you did it. How you said that those two angles are congruent. Something I would suggest, just for everyone in general, is as you're finding these angle measures, like whenever you find this angle to be 120, go ahead and mark it 120, and then you can mark this one 120 because they're vertical, and then it helps you, kind of see better. These aren't as difficult as, there are some that are a little bit more difficult, and as the week goes, each one that I put up here is going to get a little bit more difficult. But like for instance, there was one you had on your worksheet, and hopefully I have time to pass that out today. That looked like that right there, and we knew that this angle was 55, and we knew like this angle was 60, 75, and we had to find that angle over there. I think it said this angle was like 50, something like that. So first thing you had to do is find this missing angle. So they have to add up to 180. So you add these two together, subtract it from 180. That's 135. So that would be 45 here. So I would make this 45 degrees right there. Okay. Now that you have that one labeled, now I know that this is a straight angle right here. So it adds up to 180. So all three of these would have to add up to 180. 45 and 55 is 100. And so this one would have to be 80. And now all three of these add up to 180. So you add these two, which is 130 from 180. And this one would have to be 50. So at first it looked kind of confusing, but as I found each thing, I labeled it, and then it made it a lot easier. All right, what questions do you have on the bell ringer? All right, we're going to finish our notes from yesterday, so if you will please get out those notes.
Why do I test corrections?
Oh, yes. You mean 6.1 corrections?
Mm-hmm.
Okay. Any of your work from AMI that you did not turn in yesterday, get that out for me. Some of the things that we talked about was work for 6.1 practice. If you showed work, you didn't absolutely have to show work, but you did have to go back and do corrections on one unit on 6.1. So if you have that, bring it out. 6.1 corrections. You write your name on it, pass it to the front row, pass it to the right. Or any work you might have for Boom Learning. The 6.1 puzzle time, the bell ringer sheet, the test reflection. I'm trying to think if there's anything else. Oh, and on that worksheet, I'm glad that Sydney mentioned it yesterday, because on that worksheet, the very last problem, it was said it was a triangle A, all of the sides are blank, and the word they were looking for was equal for some reason, but it should have been congruent. So those of you that missed that, I will be going in there and trying to fix that. And I don't know where they got equal from, and those people that typed in equal, I don't see how you knew to put equal, because it should have said their side lengths are equal, but it just said their sides are, and it should have been congruent instead of equal. I did not catch that whenever I was looking at the worksheet, but I will be going in and fixing that. All right, so we have made it through congruent polygons, and in order for them to be congruent, all three angles or all angles and all corresponding sides all have to be congruent. And then we went through about listing all the corresponding parts and writing congruent statement, and then we even got as far as to show that two polygons are congruent. And let's go ahead and close our Chromebooks, please. To show two polygons are congruent, and to do that, you have to show that all angles are congruent and all sides are congruent. Now, if something's marked congruent, you don't have to go about showing me that, telling me that. If we were in pre-AP geometry, this would be like a proof. And the first part you would have to do is list all the given information. So you would have to say, RS is congruent to QR because it's given. RT is congruent to TR because it's given. ST is congruent to TQ because it's given. And I'm not going to have you do that. The only thing I'm going to have you do is show how the other stuff's congruent that's not already marked congruent. So yesterday on this one, we talked about all three angles, how they were congruent. Anytime you have parallel lines, you're going to have alternate interior angles. So if you see a pair of parallel lines, look for alternate interior angles. Alternate interior angles are going to be opposite of each other, just like the picture from chapter 3. You know, this one and this one are alternate interior angles. They're opposite of each other. And then these two are alternate interior. So for instance, S and Q are alternate interior, so they're congruent. P and R are alternate interior, therefore they're congruent. And then these two angles here in the middle, I can't call them angle T because there's 1, 2, 3, 4, 5, 6, 7, 8 angles here at T, so you can't call it angle T. So this angle is angle PTS, and this angle is QTR, and they're congruent because of vertical angles. Or you could have said third angle theorem. Either one would work because I've already proven that those two are. So I could either use third angle theorem or vertical angles there. That's the other one you want to look for. You want to look for alternate interior angles and you want to look for vertical angles to show that angles are congruent. If there's parallel lines, you're going to have alternate interior angles. If the two triangles are connected, you're going to have vertical angles. Okay, so I believe we got all the way through that one. Did we make it through this one here?
Yes.
Okay, again, parallel lines, so these are alternate interior angles. Therefore, they would be congruent, or you could have used third angle theorem to show that they're congruent because the other two are marked. Anytime two polygons share a side, you're going to use reflexive property, okay, because it's congruent to itself. So we have DB is congruent to DB by reflexive property. All right, so then here is the third one. It says in the diagram, show that triangle ABC is congruent to triangle CBA. Okay, now it's up to you if you want to go about doing the sides first or the angles first. Okay, what do y'all prefer to do? Angles or sides?
Sides.
Do the sides, okay. These two sides, AD and BC, are already marked, and then DC and AB are marked. So I need to figure out the third side of this triangle. Okay. Grace, what would be the third side of triangle ADC? AC, okay, so here's AC. And then that's this side here. And then what would be the third side of triangle ABC, Brett? CA. Okay, Taylor, can I say that segment AC is congruent to segment CA? Am I allowed to say that?
No. Right.
Why not?
Well, yeah, you can. Yeah, they are.
Why not? Why?
I don't know. There's R. That's all I know.
How can AC be congruent to CA and I did not know the length of either one? And it wasn't given that they're congruent. How do I know that they're the same length even though I don't know the length?
Is there a line on it?
I drew those lines. Nick?
Because it's the same line.
Yeah, it's the same exact line. This marker here, I don't know the length of it, but here's a marker, and I'm going to move it over here. Is this marker going to be the same length to itself? Or let's do it this way. Here's this marker. Here's the same marker. Is it congruent to itself? Yeah, it's the same thing. If this is 6 inches, this is 6 inches. Okay, so it's always gonna be 6 inches, no matter where it's at. So those two are congruent, and it's because they're the exact same line, and we call that reflexive property. Anytime you say that a side or an angle is congruent to itself, it's reflexive property. If you were to look in a mirror, you would look exactly the same in the mirror. You'd be the same measurement, unless that mirror is, disoriented. Sometimes, I think they tell us that we make ourselves look 10 times better in the mirror than what we really are. Okay, so that makes the third side, so I'm done with sides. Now I need to prove 3 angles. Well, I have these 2 angles marked congruent already, and I have these 2. Somehow, I need to say that angle D is congruent to angle B. Third angle theorem. So they are congruent, and that's my third angle theorem.
This isn't that hard.
It depends.
Does it get harder?
There are some that are hard, but it really, some people can just like look at it and see right away what they need. Others, it's kind of hard to see something, because if you're more of an algebra formula person where I give you a formula and you use the same exact formula for every single problem, then this is probably going to be hard for you, because you have to be visual, creative. If you're more of a formula-driven person, then geometry can be hard.
This is the highest grade I've ever had in any of my math classes ever.
I would say usually people that suck at algebra are usually pretty good at geometry. People that are awesome at algebra usually have a hard time with geometry. Unless you're just like really good at math. And you do everything really good.
Why do we have to know this stuff though? It's not like we're gonna use it really in the real world though.
It depends on what you're going to do. If you ever remodel your home, you're going to need to know it. Or algebra, I would say you use a lot more than other stuff. But like algebra 2, like whenever like people say they need to learn about taxes and interest and all that stuff, you actually do that in algebra 2.
I did not remember doing that.
They just don't call it that. They just show you how to use percentages and use formulas for interest. That's what taxes and stuff are.
Wow.
All right, this one here, it says find the measure of angle P. So we're going to use corresponding parts of congruent triangles and polygons to find missing angles and missing sides. Okay, so to do that, you need to make sure that you know that the 2 polygons are congruent or that the angles are congruent. All right, so this one here, I noticed has this mark, which means it's a 90-degree angle. So I'm going to go ahead and mark that 90 degrees. And I noticed this triangle PQR also has one that's 90 degrees. And then I noticed that this triangle here is 52 degrees, and angle A is marked congruent to angle R. So if they're congruent, then angle R is also 52 degrees. And it wants me to find the measure of angle P, which is this angle here. Okay. Well, I know from 6.1 that all 3 angles have to add up to 180, so I just do 90 plus 52. That's 142, and then I do 180 minus 142, and that gives me 38. So the measure of angle P is 38 degrees. Now, my question is what if they ask me for the measure of angle B? Am I going to have to go through and do a bunch of math again? Why not?
Third angle stand really, so it'd be 38 degrees on the other side of the congruent.
Yeah, if these are congruent and these are congruent too, so that means B and P would also have to be congruent, so it would also have to be 38 degrees. Now, if they were to give you a side, let's say this is 8, 4, and 12. that would never really work, but just, let's say it would be 8, 4, and 12. And I were to ask you, what is the length of segment PR? How could you go about finding the length of segment PR? And let me put inches so you know that this is measurements.
Well, they'd be congruent, wouldn't they? So PR would have to be the same measurement as AB, so it'd be 12 inches.
How did you know that PR and AB were to be the same?
I just looked from the way that they're, and I like turned it in my head, and it looked like they matched up, so it'd be AB and PR. I don't know.
Yeah, perfect. So AB is between the 1 and the 3 marked angles, 52 and 38. So PR is between 52 and 38. So these would have to be congruent. So if that one's 12 inches, this one would be 12 inches. QP, that would go along with CB. So this one would have to be 4 inches. And QR would have to be 8 inches.
Why wouldn't that ever really work?
Because of Pythagorean theorem. 8 squared plus 4 squared has to equal 12 squared. And two sides of a triangle, if you add them together, it always will be bigger than the third side. And 8 plus 4 is equal to 12, not bigger than 12. That's something we'll talk about later on. Okay, try this one. Find the measure of angle BDC. Find the measure of angle BDC. And you might want to look and see if I whited out some of the angles. It looks like I whited out angle A, 45 degrees. So mark angle A, 45 degrees. All right, now there's a lot of different things that you can do here to find this measure of this angle. First, you need to figure out which angle is angle BDC. So what I would do is follow the path from B to D to C. So there's B, D, C. So that's this entire angle. Well, I know this part here is 30. I've got to find this part over here. Like I said, there's a bunch of different ways you can do that. You can either use what we have talked about in the previous section about angles adding up to 180 and then using a linear pair, finding the missing angles and all that stuff. Or you can look at this like it's two big triangles. Look at triangle ACD. Triangle ACD. Here's A, which is 45 degrees. There's C, and then here's D, and that one's 30 degrees. Okay, so that's this big triangle here, ACD. Then you can also look at this other big triangle, which is BDC, and angle C is congruent to that angle over there, and then angle B is here. Okay. Well, first, if angle A is 45 degrees, and angle C is 30 degrees, then hopefully I can find out these two angles that are congruent. Maddie, what would be the measure of angle B?
45.
How'd you know?
Because it's congruent to A.
Perfect, because it's congruent to A. And Bailey, what about the measure of angle C down here? What would it be?
30.
Why?
Because it's congruent to B.
Yeah, perfect. So it's congruent to this one down here, it would be 30, so that one would also be 30. Now they're wanting the measure of angle BDC, which is this angle right here. Can we find the measure of that angle now?
Mm-hmm.
Yeah. Lakin, tell me how to find it.
You do 45 plus 30, and that is 75, and then you do 180 minus 75.
And what does that give me? 105?
105.
So this angle here is 105 degrees. For me, that's what I would use to do it, because to me that makes it the easiest. Some people have a hard time picking pictures apart, like seeing the bigger picture. Cause what I did, I saw this big triangle here and this big triangle. Now, some people have a hard time seeing that. So if you're one of those that have a hard time seeing that, what I would do, if I was you, if you can't pick apart the picture, this one's 30, so that means this one here would also be 30 degrees. So then you can find the measure of this angle. 30 plus 30 is 60. 180 minus 60 is 120. So that means this angle here is 120 degrees. These two have to add up to 180. So if this one's 120, this angle has to be 60 because they add up to 180. That's 45. This is 45. Now you can do 60 plus 45, which is 105. 180 minus 105 is 75. So this angle here is 75, and then to find BBC, you just add these two together, 75 plus 30. It's more work, but it's better for those that don't see the overlapping triangles, the big picture. Which way makes more sense to you? This way here, going through and just marking all the angles, figuring them out, or picking apart the,
Just going with it.
do what?
Just going through it. I'm going through each one.
Like this one here.
Yeah.
I would use whichever way makes the most sense to you. Alright, so this one right here says, find the measure of angle DCN. So before I have you get with your partner, first you need to fill in the missing degree, the missing measure. And then you need to figure out which angle is angle DCN. So what angle are they asking you for?
The second triangle on that side for the C.
This one here where the C's at? Yeah, so they're asking for this angle right there. Alright, so go ahead and turn to face your partner, work it out together. Natalie, can I get you to work with Taylor and Grace, please? I think the measure I write it out was the 68.
Is that one end?
That's very nice. Yeah, kind of. Oh, wait, no. Well, once you find that. Yes.
Alright, Nick, explain to me yours and your partner's thought process on how to find this measure here with the question mark, angle DCN.
Well, on this triangle over here, it has a line on it, which means that's congruent. And there's a line on this one. So we thought that 75C would be that question.
Well, this means that the segments are congruent. It does not mean that the angles are congruent. It just means the segments are. else that might be congruent with the angle?
Yeah, the DNS or so D would be 68 degrees.
Okay. Are there any other angles that are either marked congruent or that I could mark congruent? Remember, you always want to look for parallel lines. See if there's any parallel lines marked. If there is, you're going to look for alternate interior angles. If there's no parallel lines, then the next thing you're going to want to look for is vertical angles. Do you see a pair of vertical angles?
No. The only one I see that could be the same is 75.
Maddie, do you see a pair of vertical angles? That's fine. Yep, so these are vertical here, so that means they're congruent. Is there a way for me to find the measure of this angle here? Yep. Okay, what did y'all get for the measure of this angle? 37, is that what y'all got over there too? Okay, so if this one's 37, how much is this one gonna be? Okay, now we know that these two are congruent and these two are congruent. So what does that mean?
75.
Now this one's congruent because of third angle theorem, which means it's 75 degrees.
No, you make dot that or what? Wait, they're thinking though, could that still be the right answer any time?
No, because you could have this, and this is 75. That does not mean that this is 75. And you can look and see that it doesn't even look like it's the same. Let me show you. You can tell easily there that they're not the same. Even though these two segments are congruent, these two angles are different.
Okay.
The only reason why they're the same is because these two were already marked. All right, good job. Next thing, look at the picture on the board. The only thing that we know that you see is that this angle here is a right angle, like this whole thing. Like angle DCB is a right angle. Angle ABC is a right angle. And we know these two are congruent. That one's 33 degrees. Let me make sure there's nothing else that they marked. Nope, okay. So this angle here is 33 degrees. They want you to find the measure of angle 1, which is this part here. Okay? You and your partner discuss it. See how you would go about figuring that out. And if you want to draw the picture on your paper,
45.
draw the picture on your paper and figure out how you would go about solving that.
Well, you want us drawing it?
Yeah, it'll probably be helpful if you draw it. make sure you talk with your partner, even if you're not sure, I would say, okay, like, I see this, and then your partner might be like, well, I see this, and then when you work together, you might be able to come up with something. You can only use alternate interior when there's parallel lines. The parallel lines on that. An alternate interior would be opposite of each other on the same transversal. So like alternate interior would be, so were you saying these are alternate interior or these? Okay, that works. Now, the only reason for that is because these two, this line and this line are perpendicular to the same line, which makes them parallel.
I just need both of these. I got 57.
Alright, just in case, if you and your partner are figuring it out, you're good. If y'all are still having trouble, I drew the two triangles separately, the two right triangles separately to try to help you. And then once you find the missing angles, then you can go back and figure out the other ones. Alright, who thinks they have it figured out?
We don't have the answer yet, but I think we're getting somewhere.
Okay.
I think I might have the answer.
Okay,
I got,
explain to me your thought process.
so I did,
Let's see.
you have 33 and 32, 33, so A is congruent to D.
Wait, let me, use a different color. Alright, do you want me to mark it in this top picture or down here?
It doesn't matter.
Okay, so this one's 33. Okay,
And then you have 90 on like, well, down and bottom picture, both of them are 90. So you have 33 and 90 degrees. And so if you take 33 plus 90, minus 180. Yes, and then that would be your C, which would also be your B.
now this isn't the entire C, this is just this part here, correct?
Yes. And so then for that one, wait, wouldn't that top one now would be, yeah. And then you have, is that 40? No. 90 minus,
What's 90 minus 57?
33, yeah, I think.
Okay. Was someone else able to figure out that that was 33 using something different than what they just used? Natalie, will you, explain to the class y'all's thought process?
We basically did that thing, but, I've no idea where it was.
You know, I just had like
Alternate interior.
Yeah, but we did that and found, 33 for angle one, I guess, and then the other part of angle one.
Okay, so here, the reason why these two lines are parallel is because they're perpendicular to the same line. And since they're perpendicular to the same line, that makes these parallel. Here's A, and here's C. She's saying that angle A is 33, therefore this angle here at C, at the top of C, is also 33 because of alternate interior angles. So you could have done that really without doing any, actual math. By using alternate interior angles. Alright, here's another one.
Taylor, you got algebra?
Kinda. I'm better at this now. Until it comes to whatever we said. I was so lost in that. That made no sense.
You don't, you don't know.
That's why I didn't know.
Alright, there's another one. Find the measure of angle 1.
It's T80.
Yes.
Well, X and those are
And 54.
yeah, I think this one.
I got it.
Bailey, explain to me your and your partner's thought process on finding the measure of angle 1.
I would just say 80 plus 54. And, yeah, and then there's 180 minus 134. That's 43. And then, right?
Well, what's this right here, 46 degrees? What does that give you? For you, okay. Only time you're going to use alternate interior is if there's some parallel lines, but there's not any parallel lines. But it's wanting the measure of this angle here, x. Is there anything we know about x? We got a 4 here. What do you notice? What do you notice is by angle x? Okay, what's it congruent to? It has one arc on it. Like here, S and D are congruent because they each have one arc. This one has one arc, so which angle is it congruent to? U. And what's the measure of angle U? So what's the measure of this one going to be?
Good job. Boy,
There
you're
you go. Okay. What questions do you have for me? Alright, these notes are page 29, and then I have some papers to pass back. After I'm finished passing back papers, then you can put your stuff up. I also have your vocab. Your vocab needs to go in your binder. So make make sure you put your vocab in your binder. It is, I can't remember the page now.
27.
Your vocab is page 27.
And then 26.
26? 26.
How many like lessons are with this chapter?
There's like 7, but I'm gonna, there's gonna be 3 or 4 that I actually cover for this chapter, and then I'm gonna make part of it a whole nother chapter.
Okay.
I also have your 6.1 puzzle time worksheet. You're gonna wanna look over this for the, quiz on Friday, because your quiz is gonna be 6.1 and 6.2. Alright, that's all I have. Okay, you can go ahead and put up your calculators and get your phones.
Then get my handwriting.
And someone gave me their student journal. Let me get it for you.